Hey, good morning, and thanks for choosing to watch SES Engineers' webinar today. This is just one of many we're producing that are focused on carbon sequestration and deep injection well educational information. In this episode, Ms. Kokil Bansal will discuss what differentiates a good well from a bad injection well. She'll tell you a little bit about the history of injection wells and provide some tools to help anyone who's considering this technology get off on the right foot. Kokil is a licensed professional engineer with experience in landfill redevelopment, site assessments, geologic sequestration, wastewater permitting, and advising her clients on sustainability practices. She holds a bachelor's in chemical engineering and a master's in environmental engineering. Kokil, stage is yours.
Thank you so much, Stephanie. As Stephanie mentioned, my name is Kokil Bansal, and we will be talking about the good wells and the bad wells. So let's start with a brief history lesson. The deep injection well technology has been around for quite some time, since the 1930s, and it started with the oil and the gas companies when they started injecting waste into depleted reservoirs. This was then followed by the steel industry, the chemical industry, and then the municipalities. And up until this point, which is the 1970s, the wells were regulated by the states. And because each state had different standards of protection of groundwater, the way they were regulated were also different. So when the number of wells began increasing in the 1970s, EPA became concerned about protecting groundwater, which is basically your drinking water source. They were able to regulate some injection wells under the earlier regulations, but clear standards were established in the 1980s. That's when Congress passed laws requiring additional regulations. And from 2000s and even up till now, they keep revising and regulating more wells, for example, the carbon sequestration well. There are 6 different classes of deep injection wells, and each of these classes regulate different types of effluents. For example, the class 1 well has hazardous and non-hazardous municipal wastewater. The class 2 is usually used by the oil and the gas industry. Class 3 wells is used by the mining industry. Class 4 is again hazardous. Class 5 is experimental, and Class 6 is the new carbon sequestration well. So as I mentioned from the previous slide, EPA started regulating these wells in the 1980s. However, for example, the Class 2 wells were used before these regulations came out by the oil and the gas industry. And I also wanted to talk about the difference in the hazardous waste wells, which is the Class 1 and the Class 4. So as you can see, the Class 4 wells from the figure, Class 4 wells are injecting their effluent in the saline aquifer, which is basically below your confining layer. However, the Class 4 wells is injecting into the USTW or slightly above it. So when EPA started regulating these deep injection wells in the 1980s, they banned the use of Class 4 wells because of the health risks involved with them and because the standards were different back then. I also wanted to show you the typical deep injection well in this slide. So you can see on the right side, wherever you have the drinking water source, you have several confining units, followed by the confining zone. And then you have the injection zone, which is below the confining zone, so that a deep injection well is disposing of the effluent correctly and is being protective of your drinking water source, which is your USTW. So as you can see, we have a 50-year history of virtually no regulation of the deep injection wells. And as the media and the public started getting more involved, there were a lot of questions about the issues that the deep injection wells were causing. there was a growing concern about the seismicity and the contamination of the USDW. The map here on the screen on the left side shows the number of earthquakes in the region, and there was a lot of speculation about the correlation with the deep injection wells. Now, there is still a lot of research that is being conducted to understand the factors that could relate the earthquakes and the deep injection wells, and factors such as timing of injection, the amount, and the rate of the waste fluid injection are being observed. Now let's step back to the different classes of the deep injection well that we talked about in the previous slide. Current research suggests that most wells that are associated with injection-induced earthquakes are those that inject high-pressure fluids, for example, the Class 2 wells. Now, remember, Class 2 wells have been there for a long time, and they were usually installed pre-1980s. That's when they were. We can redo this part. Now, due to the fact that these wells generally involve higher pressure, there is a small confined underground reservoir with low permeability. So think of it this way: you keep injecting a high pressure fluid, but that fluid has nowhere to go because the porosity is so low, the pressure builds up. And that's when issues start occurring in the geology. And we will talk a little bit more in the next slides. Now, most of the wells today are Class 1 deep injection wells. And research has shown that only a small fraction of more than 30,000 US wastewater disposal wells appear to be associated with damaging earthquakes. And most of the Class 1 wells today were installed after the 1980s, which is when the regulations were passed. So these wells are protective of a drinking water source. Again, remember, we have 50 years of virtually unregulated wells. Those wells still exist today. So it's very important to understand why there is a public perception about the deep injection wells and where it stems from. So let's take an example of an improperly designed well that we discussed in the earlier slide. As I mentioned, this type of well usually has a high pressure injection. And when this kind of well is installed in an area with low permeable soils, the pressure builds up. When this increasing pressure is in the proximity of a fault, it weakens a fault and a slip occurs, causing an earthquake. Another issue of this increasing pressure is that it causes fractures in the confining zone, which means if you have a leak, it could migrate upwards. These issues occur when there is an improper siting and an operator does not understand the geology of the location where the well is being installed. Another important factor to consider is the interaction between the injected wastes and the fluids and the minerals in the receiving and confining formations. So if there is two incompatible fluids that are getting mixed, chemical reactions can occur and solids precipitate out. So think of it this way. Again, you are creating like a block. So if you have a high pressure fluid coming in and there are solids which are preventing its path, again, your pressure builds up and you get issues that we talked about earlier. The third factor is there can be negligence at the time of installation. For example, poor application of the cement causes waste to enter the well shaft, and again, fluid moves upwards and into the drinking water source. Also, leaking casing or tubing could result in waste migration and groundwater contamination. Failures in pressure monitoring or faulty gauges leads to excessive pressure buildup and subsequent failure of the injection equipment. Sometimes an operator can continue pumping effluent into a deep injection well, not realizing that there is something wrong with the gauges. And when the pressure builds up, it can cause fracture of the rocks, it can cause crack in the walls. So what all this means is that if there is improper siting, there are design challenges, the geology and hydrology has not been understood, it can basically make your deep injection well into a bad well. So since the 1980s, EPA and the regulatory agencies have made great strides to regulate wells correctly and have a huge list of requirements that an applicant needs to adhere to for the installation and operation of a deep injection well. Understanding the EPA and state regulations are important before starting the process. And the organizations have listed out several items that an applicant needs for the permit. The second thing is the technical considerations. Before any site installs or before an applicant decides to install a deep injection well, the makeup of the rock formation, which is the geology, and the relationship with the local and regional aquifers, which is your hydrology, must be understood. The site operator should be able to provide detailed description of the different rock layers that the well may pass through, the thickness, the size, the position in the Earth's crust, the rock makeup, in addition to that, the rock characteristics. And to design a well properly, they also need to understand the porosity, the permeability, compressibility, and stress characteristics for the rocks. These understandings of the geology and hydrology are so important for determining the risk of induced seismicity from the injection. Another factor is the economic consideration. As part of the regulatory review, financial assurance needs to be provided so that a client understands not just the capital cost of investment, but also the maintenance cost. So it's very important that the finances are hashed out before the process can begin. And the last one, although this is listed in the bottom, the community engagement aspect is also very crucial to the process. The community needs to know when there are plans to install a well, the location of it, and what all steps the applicant is making to make sure that the well is not going to cause an issue for the drinking water source or cause any other problems that we discussed in our earlier slides. So a well that is properly designed, has good siting, suitable geology, is properly maintained and has regular sampling monitoring and has financial assurance for the proper maintenance of the well is a good well that is protective of the groundwater and is a responsible discharge option for any kind of effluent, as long as an applicant manages to take these factors into consideration. A deep injection well is a responsible fluid disposal option. I will leave you with a few key things that we learned today. So the number one is proactive engagement. Although this is an afterthought many times, it is so important to talk to your stakeholders, the public, the local environmental advocacy groups about the plan and how and where the wells will be installed. If they are involved early in the process and more they understand the benefits and factors that you as an applicant are taking into consideration, the better and smoother the process will be. So even if somebody comes in with misinformation, they have the right information from you. So as I say, think of it this way. They will get the information from somewhere, and it's always better that they get the facts from you. The second is understanding the site geology. Installing a well with the right geology is the key. We highly recommend that before a well is installed, a feasibility study be performed so that we can minimize uncertainty and have a robust site characterization. And the third is the fiscal costs and benefits. A deep injection well is a high capital investment project, and there are maintenance costs for the life of the well. An applicant should have resources for the entire duration so that we can be protective of the water and be a responsible user. So thank you so much for watching the presentation. You can contact our teammates on the email addresses listed here and scan a QR code for more information. And now I will hand it back to Stephanie Hill.
Thanks, Kokil. Very good information. If you've tuned into some of our other webinars, you probably noticed a theme of community outreach. We cannot stress enough the importance of proactively engaging with your local communities for successful and timely environmental project execution like deep well injection. Kokil, along with her colleagues on the SES team, have presented on many other topics in this webinar series, so please check out those recordings and join us again for more upcoming topics that are in development now. You can reach out to Kokil or a few of her others on the team by scanning the QR code to learn more about how we can help you. On behalf of the SES Carbon Sequestration and Deep Well Injection team, thanks for tuning in.